Hi. Today's class we are going to discuss problems in alternating current. Previous class we have done theory of AC. Now we are going to see problems in AC. A 100 ohm resistor is connected to 220 volts 50 hertz AC supply. What is the RMS value of current in the circuit? What is the net power consumed over a full cycle? First problem, IRMS is equal to VRMS by R. Whatever value given in the problem, if it is not mentioned otherwise, it is called RMS value only. Maximum value means maximum value they will mention in the problem. If it is not mentioned means it is RMS only. So connected to 220 volts. So 220 by resistance is 100 ohm. So current is 2.2 ampere. This is A. B is what is the net power consumed? Net power consumed means power is equal to V into I. In our case, VRMS, IRMS. VRMS is 220, IRMS is 2.2. 220 into 2.2 is 484 watts. This is the power consumed. Okay. Second problem. The peak value of an AC supply is 300 volts. What is the RMS voltage? Peak value of AC supply is 300 volt. What is the RMS voltage? RMS value of current in an AC circuit is 10 ampere. What is the peak current? So, first case, RMS voltage is asked. VRMS is equal to V0 by root 2. That is 0.707 V0. 1 by 1.414. That is 0.707. What is the maximum value given here? 300 volts. So 0.707 into 300. So 70.7 into 3. 212.6. 16 volt. This is RMS value of voltage. Second, what is the maximum value of current if RMS value is 10 ampere? IRMS is equal to I0 by root 2. I0 is equal to IRMS into root 2. This is 10 ampere into 1.414. So 14.14 ampere. Maximum value. I0 we can put or IM we can put. Anything we can write for maximum value. IRMS is equal to IM by root 2 or I0 by root 2. Both represents maximum current. VRMS is equal to VM by root 2 or V0 by root 2. Both are correct. 44 millihenry inductor is connected to 220 volts 50 hertz AC supply. Determine the RMS value of the current in the circuit. 40 millihenry inductor. Question is you have to calculate RMS value of current. Same formula, IRMS is equal to VRMS by R. In this case, resistance offered by the inductor. Resistance is not given. Resistance offered by the inductor is called XL. XL is equal to L omega. L into 2 pi F. What is the inductor given value? It is 44 millihenry. into 10 power minus 3 into 2 pi into f value is 50. So 44 into 2 into 50 is 100, 10 power minus 3 is 10 power minus 1 into 3.14. So XL value is 13.816 ohms. RMS value of voltage, that's what we have discussed. Generally, if it is not mentioned, it is called RMS value only. So IRMS is equal to 220 by 13.816. That should be 15.9 ampere. 15.9 ampere. Okay, fine. Next step. Fourth problem. A 60 microfarad capacitor is connected to 110 volts 50 hertz supply. 60 hertz supply. 60 hertz. Determine the RMS value of current. Before calculating the current, we have to calculate resistance. Previously, for inductance, we have written XL. So IRMS is equal to VRMS by XC. XC is nothing but resistance offered by the capacitor. That is called capacitive reactance. So 1 by C value will be 60 microfarad. 60 into 10 power minus 6. Omega is 2 pi nu or 2 pi f. So 2 pi into 50. Calculate the XC value. 44.23 ohm implies IRMS is equal to VRMS by XC. It is 110 volts. 110 by 44.23. Simplify. 2.48 ampere. So using inductive resistance or resistance offered by the inductor, XL is equal to L omega. Based on that, we have calculated RMS value of current. See, this current is more. Next, capacitive reactance. Capacitive reactance is 1 by C omega. So that will go to numerator. Okay, so total value will be less comparatively. That's okay. So 2.48 ampere. Total value is more means resistance offered by the capacitor is more, but current is less. RMS value, what we are getting here. There is no comparison between resistance offered by the inductor and capacitor. Depends upon the value. Okay, so we need not confuse about it. Question number 5. Obtain the resonant frequency of a series LCR circuit with L is equal to 2 Henry, C is equal to 32 microfarad, and R is equal to 10 ohms. What is the Q value of this circuit? Obtain resonant frequency, that is first one. What is the Q value of this circuit? That is second part. First part, resonant frequency. There are two things here. Resonant frequency or resonant angular frequency. Resonant frequency means F. Resonant angular frequency means omega 1 by root of LC. So the given value L is 2 Henry. 1 by root of 2 into capacitance value is 32 microfarad. 2 into 32, 64. So 1 by 8, 10 power minus 6, outside 10 power minus 3, numerator 10 power 3. So 10 power 1000 by 8 is 125 radian per second. No, sir. F I want to calculate 1 by 2 pi omega is, this is 1 by 2 pi root of LC. So 1 by root of LC is omega by 2 pi means frequency can calculate. No problem. Second part, you have to calculate Q factor. Q factor or quality factor formula, Q is equal to 1 by R into root of L by C. What is R value here? 10 ohms, 1 by 10, root of 2 Henry by 32 microfarad. 2 and 32, if you cancel, it will become 16. Outside, it will become 4. 10 power minus 6, outside 10 power minus 3. 10 power 1, 10 power minus 3 is 10 power minus 2. Numerator 10 power 2. So Q will be 100 by 4. That is 25. So 25, there is no unit here because it is voltage across the inductor by applied voltage. Voltage across inductor or capacitor, anything you can write by applied voltage. So the value is Q is equal to 25. Okay, well, it is a ratio. So there is no unit here. Fine. Problem number 6. A charged 30 microfarad capacitor is connected to 27 millihenry inductor. A charged 30 microfarad capacitor is connected to 27 millihenry inductor. What is the angular frequency of free oscillation in the circuit? Just now we have seen the formula. Angular frequency omega is equal to 1 by root of LC. Omega is equal to 1 by root of L value 27 into 10 power minus 3. C value 30 microfarad. 30 into 10 power minus 6. 10 power minus 3 minus 6. 27 degree 81. 81 square root is 1 by 9. 10 power minus 3 minus 9. This is 10. 10 power minus 8. Outside is 10 power 8. 10 power minus 9 minus 8. Outside is 10 power minus 4. Numerator 10 power plus 4. 10,000 by 9. That is 1111 radian per second. This is resonant angular frequency. In the same question, resonant frequency is asked means we have to write 1 by 2 pi root of LC or omega by 2 pi. Omega we have calculated, by 2 pi will be the answer. Okay. Fine. Next. Seventh problem. Suppose the initial charge on 30 microfarad capacitor is 6 millicoulomb. What is the total energy stored in the capacitor? Energy associated with the capacitor is, you know, U is equal to Q square by 2C. Q square by 2C is energy associated with the capacitor. What is Q value here? 6 millicoulomb. 6 into 10 power minus 3 the whole square by 2 into C value 30 microfarad. 30 into 10 power minus 6. 6 square 36 and this is 6. So again 6 here. 10 power minus 5. This is minus 6. So 10 power minus 1. 0.6 joules. That is energy associated. Later time, what is the change they are asking? No change in energy at later time. Initially, after charging, what is the energy question? Same energy, no change. Okay. Question number 8. In an electrical circuit or LC and AC voltage source, all are connected in series. When L is removed from the circuit, the phase difference between V and I is pi by 3. Whereas when C is removed, the phase difference is again pi by 3. Calculate the power factor. Generally, power factor in RLC circuit, power factor is represented by cos phi. Formula R by Z. Resistance by impedance is called the power factor. Okay, R by Z. First, R we have to calculate. XL, XC we have to calculate. In RC circuit, question, when L is removed, phi is equal to tan inverse of XL minus XC by R. C is removed. First, L is removed. L is removed. RLC circuit, L removed. So remaining XC by R. What is the value? Pi by 3. Given, it is given in the problem. When C is removed, phi is equal to tan inverse of XL by R. That is also pi by 3 is a question. So, phase angle is same. Phase angle same means the resistance offered by the inductance and the capacitance both are equal. That means here XL is equal to X. Tan 60. Pi by 3 means tan 60. Root 3. Both case root 3. So we need not worry about it. What is phi value? Enough. This is 60 degree. So cos phi will be XL is equal to XC means R by root of R square plus XL minus XC the whole square is a formula. XL minus XC the whole square. This is 0. Both are equal. So R by R. So cos phi is equal to 1. So power factor is 1 in this case. Okay. 9th problem. In a series RLC circuit, the voltage across 100 ohm resistor is 40 volts. Resonant frequency is omega 250 radian per second. Voltage across 100 ohm resistor is 40 volts. If the value of C is 4 microfarad, then calculate the voltage across L. resonant frequency question. So straight away we can write XL is equal to XC, that is equal to 1 by C omega 1 by 4 into 10 power minus 6. Omega value given as 250 radian per second. 4 into 250 is 1000. 1000 into 10 power minus 6 is 10 power minus 3, numerator plus 3. So this is XC. That is equal to XL also. Resonant frequency only question. Now what is the current? Therefore, I is equal to V by R. This is 40 volts. R is 100 ohms. 40 by 100. 0.4 ampere. What is the voltage across L is also asked. XL VL is equal to L omega 0.4 into omega is 250. 250 means 25 into 4, 100 volts. I is 0.4. 0.4 into I into XL. I into XL. I is 0.4. What is XL? 1000. So it is 400 volts. We have multiplied omega. Omega we know. XL is equal to I into XL, current and resistance. Okay. Question number 10. An inductor 20 millihenry, capacitance 50 microfarad, and a resistor 40 ohm are connected in series across a source of V is equal to 10 sine 340t. 10 sine 340t. Find the power loss in AC circuit. It's a beautiful question. All the factors you have to calculate. XL you have to calculate. XC you have to calculate. Impedance you have to calculate. Z. First XL. L omega. What is L value? 20 millihenry. 20 into 10 power minus 3. Omega V is equal to V naught sine omega t. This is basic equation. So omega here is 340 into 340. So 2 into 64, 68. These two zeros cancel mean 10 power minus 1. 68, that is 6.8 ohms. Next, capacitive reactance XC 1 by C omega. What is C value? 50 microhenry. 50 into 10 power minus 6. Omega again is 340. So XC is equal to, what is the value? 58.8 ohms. Therefore, Z is equal to root of R square plus XL minus XC the whole square. Z is equal to root of R square. What is the resistance value? 40 square plus 58.8 minus 6.8. So it should be 52. So 52 square. Rearrange, simplify. 65.6 ohms. You have calculated impedance only. Question is, you have to calculate power loss in AC circuit. So calculate the current now. VRMS by Z. VRMS by Z. What is VRMS value? VM by root 2 or V0 by root 2. V maximum by root 2 by Z. VM given in the problem is 10 volts. 1 by root 2 is 0.707. Z value 65.6. So denominator is high. Total value is small. 7.07 by 65.6. The answer is 0.108 ampere. 0.108 ampere. Simple. This is not a question. Therefore, power loss is equal to, see how many factors you are calculating. XL, XC, current, impedance. Okay, now we'll go for power loss. Power loss is I square R. Wherever you go, if it is not given, you have to write RMS only. So I square RMS into R. What is I square RMS value? This is IRMS. 0.108 the whole square into resistance value 40 ohms. 40 ohms you multiply 0.46 watts. So the power loss is 0.46 watts. Okay. Question number 11. The instantaneous values of AC current and voltage in the circuit are I is equal to 1 by root 2 sine 100 pi t. I is equal to 1 by root 2 sine 100 pi t. V is equal to 1 by root 2 sine 100 pi t plus pi by 3. That means voltage is leading the current by 60 degree. Question it is given. Okay, what is the average power consumed in the circuit? Power is ERMS, VRMS, cos phi. ERMS means E maximum by root 2. VRMS naka? No, E into I. This is IRMS. Maximum current by root 2. VRMS means V maximum by root 2 into cos phi. 1 by root 2 is maximum value. So power loss, power is equal to IM 1 by root 2. That is maximum value. 1 by root 2 into by root 2 into 1 by root 2 by root 2 into sin phi. No, power factor formula P is equal to VRMS IRMS cos phi. So cos pi by 3. 1 by 2, 1 by 2, cos pi by 3 is cos 60. That is also 1 by 2. So answer is average power is 1 by 8. Correct, Amma? So slightly big problem because so many quantities we have to calculate. Easy, simple substitution only. That's all. Question number 12. 20 by pi square Henry is connected to a capacitor of capacitance C. Calculate the value of C in order to impart maximum power at 50 Hertz. First part, maximum power means current should be maximum. Current the maximum means it should be resonance. Maximum current means resistance is almost XL is equal to XC. XL is equal to XC means maximum current only will get. What is the formula here? Maximum current. We'll calculate XL and XC first. So XL is equal to XC, that is a condition given. L omega is 1 by C omega. Omega square is 1 by LC. Omega is equal to 1 by root of LC. This and all we know already. C we have to calculate. So omega square is equal to 1 by LC. C is equal to 1 by L into omega square. What is L value? 20 by pi square into omega square. What is omega square? 2 pi into F. Simplify, rearrange, calculate the value of capacitance. Pi microfarad. Pi into 10 power minus 6 farad, that should be pi microfarad. Okay. Question number 13. Write down the equation for a sinusoidal voltage and time period of 50 Hertz and its peak value 20 Hertz. Frequency 50 Hertz, peak value 20 volts. V is equal to Vm sin omega t. Omega is 2 pi f. What is the value? 50 Hertz only frequency given. 2 pi into 50. Okay. V is equal to Vm sin omega t. What is maximum value? 20 volts. 20 into sin 100 pi. Into t. 20 into sin 314t. This is the given equation. In terms of V, RMS value, this is RMS value, maximum value given. This is first part. Second part. Calculate the time for one cycle. One cycle, generally time period is 1 by frequency. In our case, 50 Hertz. So 1 by 50, 0.02 second. This is 0.02 second. Okay. Fine. All problems except 1 or 2, most of the problems in alternating current is very, very, very interesting. And simple straight substitution only. So there is no need to panic or getting afraid of this. 14th one. The equation for an AC is given by I is equal to 77 sin 314t. You have to calculate peak current, frequency, time period, instant value of current at 2 millisecond. 77 sine 314 t. General equation I is equal to maximum current sine omega t. Compare these two equations. Calculate peak current. Peak current is Im. That is 77 volt. Next, frequency F is equal to omega by 2 pi. What is omega? Omega by 2 pi. Omega is nothing but 314. 314 by 2 into 3.14. 3.14 and 314 100 times. 100 by 2 is 50. 50 hertz. Straight rod. Question number 15. And one more things. Two more things here. You have to calculate the time period. 14 itself, time period you have to calculate. T is equal to 1 by frequency is called 1 by F. What is F value here? 50. 1 by 50 hertz. So that is 25. 1 by 50 is the answer, ma. 0.02 second. Instantaneous voltage and current. What is instantaneous current? I is equal to I naught sine omega t plus y. What is I naught? 77. I naught or I maximum? 77 ampere. Next, sine omega t plus phi. Omega is nothing but 314. 77 sine 314 into 2. Why 214 into 2? Time is 2 millisecond. T is 2 millisecond. So I am putting 10 power minus 3 here. Pi already, you know. Okay. Simplify 77 sine 36 degree. Calculate this sine 36 into 77, 45.26 ampere. Correct, Amma? Straight substitution. Question number 15. Capacitor of capacitance C is equal to 10 power minus 4 by pi farad. Inductor L is equal to 2 by pi Henry. Resistor R is equal to 100 ohms. These are the data. You have to calculate power factor. You have to calculate impedance of the circuit, peak value of the current in the circuit, power factor of the circuit, power factor of the circuit at resonance. So many things you have to calculate. First, inductive reactance. XL is equal to L omega. L into L is 2 by pi. Omega is frequency. 2 pi into 50. Pi cancels. 4 into 50, 200. Okay, Amma? Next, capacitor reactance. Xc is equal to 1 by C omega. What is C value? 10 power minus 4 by pi into omega. Omega is 2 pi f. Pi cancel. 1 by 2f into 10 power minus 4. Calculate f already you know 2 into 50 100 10 power minus 2 numerator 10 power 2 100 ohms. Therefore, Z is equal to root of R square plus XL minus XC the whole square. What is R value? 100 ohms plus XL minus X3. XC, XL 200. This is 100. The whole square into what else? That's all. Root of 100 square plus 100 square. 100 square plus 100 square. Straight away you will get XC is equal to 100 ohms. Z you have calculated, that is not okay. Z you have calculated. You have to calculate 141.4. $10,000 plus 10,000. 20,000. Root of 2 into 1,000. One time. So you can change it, no problem. Root 2 into 100. 1.414. This is 141.4. Ohms. Of course, ohms. Peak value of current, power factor at resonance. VRMS by Z. Okay, calculate the current will be 2.2 ampere. Power factor cos phi is equal to R by Z. 100 by 141.4. Simplify 0.707. Next, power factor at resonance. Cos phi is equal to R by Z. At resonance, both are equal. R is equal to Z. That is called resonance condition. So cos phi is 1. Okay, so these are the problems related with alternating current. So alternating current theory and the problems we have finished. Next class we will see electromagnetic induction related problems, EMI related problems. Okay, thank you. We'll continue.